Good morning, Mr. Edris. This is Hudson from New Use Paving and Building Contractors, a division of audio projects. I've been thinking quite a lot, quite often, quite frequent. The project you have at the house, the property 167 of Mayor in Westville. So I'd like to sort of, make you a bit informed and with regard to which option should you go for, because initially your option was, your preference was a Gabion wall, which might be sort of be a lot of financial resources that might be needed to fund it up, and also the duration. So, and also probably your preference for the Gabion War is might be sort of attributed to maybe longevity or strength, as compared to Lofostein. But basically, as Lofostein, as I would like to stress out, emphasize in this video, that there is basically nothing, in terms of strength. A Lofostein can just be as strong as a Gabion, because once it's actually sort of constructed properly, taking into consideration all the structural engineering specifications, then we got no need to worry about the chances of the wall to fail as time goes on, and regardless of what may happen due to heavy rains, bad weather, or whatever that might sort of cause the wall to disintegrate. So okay, yeah, I have this structure that I'm just gonna quickly uh, explain the specifications, but it's more like engineers specifications, but um, it's my own drawing that I just been working on. And okay, so yeah, this is my drawing with all the structures. The height 5.2 meters. We are going to be using the Jollof 400 manufactured by Coral Brick. And this is the excavated material that you brought on site. So this is the steepness of the bank. They already shaped, formed by the sand that was brought. That is actually on site. And these are the layers. As I said, that even in the quotation, that we are gonna need about a layer of gravel, corner to corner on the wall, as we build it all the way up, and another layer of drainage. This one, that we need to get stones that we are gonna be sort of putting to ensure that the drainage is adequate. Okay, so yeah, and this is we might need sort of some clean natural soil approved, and it should be sort of more. It should be soil that once it's compacted, it stays in place. And then if it means getting a geotech engineer to approve that, that will be done. So another thing is the design of the wall, because Uh, it's gonna have to be kept, just like how I'm trying to illustrate with my drawing here. That this is probably gonna be the shape of the wall, entire wall, as we build it corner to corner. So this is my drawing. Let me just take you back from the time I was starting to draw it. Okay, so alright, there we go. And we have our 17 meters on the from the boundary, and then we get to the front side. It's gonna be facing it's gonna be 47 meters, as I measured on site that day. Okay, so basically, yeah, this is what I was actually sort of assuming, that the wall is gonna have some caves, and also the good thing about the caves is also the shear pressure or the lateral pressure against the wall. If it's got caves, now it means it's not gonna be even. It's not gonna be distributed even. Some caves, some certain sections of the wall are gonna be experiencing less pressure, and so it's not gonna be sort of like as it caves in, it means that there's less pressure, and so that makes it strong. That's basically what I'm trying to say. And what I also proposed in the quotation is to have a drainage layer, such as this one. We need to sort of put some drain channel behind the wall, because we don't want the water to flow from the house, I mean down to the bank. If the big fill gets washed off, that will actually sort of make the wall on the vulnerable. And yeah, so this is like a drain channel, right? To water is gonna have to actually sort of get captured into the drain channel, and then we're gonna have to find out where it's gonna exit and where it's actually gonna be discharging into. All right, in the course of the job. All right, so design was another aspect. Okay, so yeah, and another thing is probably the constructional methodology. Um, so basically, as we're gonna be building up, that's when we're gonna be laying. Um, we are gonna be yeah. So I was basically trying to say that as we will be building up the wall, it's more like we lay a block like this, all right, and then we backfill and compact each course. We fill up this section here with all the layers like labeled in this sketch, the gravel, the sand, the bedim, and the clean sand, approved sand. The clean sand is going to be needed because it might reduce the quantity of or the volume of the gravel needed, because gravel is relatively expensive, and if you can get clean sand, that will gonna help us a lot, and then it's gonna reduce the amount of gravel needed. Okay, so yeah, back to the diagram. Um, so it's basically how we're gonna be building it. We actually lay another course, right, and we backfill and compact. Compaction is gonna be done with rammers, even as well as rollers, right? We lay and we backfill. Yeah, so basically that's how we're gonna be building it. Just to you lay, we lay, and we backfill after every 200 meters. We backfill and compact, backfilling and compact. That's the process until you get to the top. So I'm trying to stress that a low line is it's actually once it's actually built according to engineer specifications. The chances of failure are very very low, because if a gabion now, for structural stability of a gabion, it needs to be like 2/3 of the height just to get the base, and then as you go up we put so that's actually very expensive, and we can't compromise by saying, okay, let's just put let's just take one on top of another without having to make the base strong. I promise you, I've seen a gabion walls failing due to these in lack of proper structural engineering during construction. So yeah, as I said, okay, just a quick recapture of the presentation is the structure, or the cross section of the structure, the outlay is this well labeled structure, just like more like this detailed engineering structure. There was also a retaining wall from a structural engineer. The height was 7 meters. They also recommended using the geoloc 400 blocks to be for geoloc 400 written manufactured and supplied core brick. Okay, so that's basically straight, and the design, instead of we are gonna be making it curved, not like this straight corner to corner, the front face. So, and it's gonna be curved like how I've drawn on this picture, the 47 meters, and then the 17 meters is gonna be going up at a certain angle because the slope is actually going up. All right, so Lani, I would like to thank you so much for the opportunity you gave us once again, and then look forward to work with you over this project. Okay, all right, thank you so much.